over the horizon. Around the bend they came, a new breed of vehicle. From a distance, they looked like standard GMC trucks. But as they drew closer, the emblems of dozens of proud sponsors said something was different. The real difference in these trucks was not on the outside. The real difference was inside the cab, where student engineers from 24 colleges and universities across the United States and Canada were awaiting the challenge of the week ahead. And inside the hood, where the engines that hold the future of automotive technology had come to life. The trucks were on their way to the Sarkees Energy Center at the University of Oklahoma for the 1991 Natural Gas Vehicle Challenge, the largest, most comprehensive test of natural gas vehicles ever staged. Donated by the General Motors Corporation, these shiny new 1991 trucks were initially designed to be fueled by gasoline. But they became the focus of this redesign organized by the Argonne National Laboratory and the Society of Automotive Engineers, because today, gasoline is fueling more than just automobiles, it's fueling great concern.
We face a real dilemma with gasoline. We know that it's a finite resource, and we see our dependence on imported oil growing every year. We're already over half dependent on imported oil, and we unfortunately cannot even produce enough oil in our country to power our own transportation system. Plus the fact we are realizing that we have a severe air quality problem in this country, and gasoline, although it's a great fuel, has been shown to be a major contributor to air pollution.
The U.S. Department of Energy and its Canadian equivalent, Energy Mines and Resources, have joined with the state of Oklahoma and SAE to sponsor this student engineering research competition. Intended to provide a hands-on learning experience for the leaders of tomorrow's automotive industry, the NGV Challenge also focused on advancing the state of natural gas vehicle technology, because natural gas has numerous advantages.
Natural gas is an excellent fuel technically. It's also an excellent fuel economically, and we have it in a relative abundance in the United States and Canada.
The engine technology required to get the most out of natural gas has not yet been developed, but the student engineers' unbridled imaginations are a key element in beginning the development process.
Although the major manufacturers, General Motors in particular, they'd like to be on the forefront of all technology, there's many other minds out here, young, innovative, creative minds that might have thought of a new, better mousetrap or approach, application of achieving a goal that someone else hasn't thought of.
As professionals from across the automotive industry judged these vehicles on their design's innovativeness and feasibility, they did indeed find a variety of approaches.
To increase our fuel economy, we came up with a variable displacement system on the motor, which is just basically some solenoids that turn off valves, 2 at a time, so we can run on 4, 6, or 8 cylinders. We run on 4 cylinders when we need the fuel economy, 8 cylinders when we need the power.
We have tried 4 different fuel delivery systems. We have seen what has worked, and we have a state-of-the-art system.
Many schools use fuel injection systems, turbocharge their engines, some use superchargers, but we went with a basic mechanical feedback system, which we believe to be very reliable, and it has proven to be very reliable.
Reliability was not necessarily an easy factor to maintain, especially in categories like the cold start test, where each truck was frozen to 20 degrees below zero, then checked on its ability to start and keep running. This test was conducted in facilities at the National Institute for Petroleum and Energy Research in Bartlesville, Oklahoma. While at the institute, the trucks also underwent a detailed federal exhaust emissions test. Technicians at the lab sampled the truck's tailpipe emissions for a number of pollutants, then checked the levels for compliance with Environmental Protection Agency laws. From here, the NGV Challenge really picked up speed as the teams moved to the University of Oklahoma for the rest of the events, including the acceleration trial. After receiving a last-minute word of advice on this event from a teammate, each driver pulled their truck to the timing line and waited for the flag. Then they were off, gunning their natural gas vehicle down the quarter mile to the finish line with a 1,000-pound payload in the bed. Each team hoped their truck did well, of course, but they didn't want it to roar down the track either, because nearby an engineer was measuring exhaust noise and assessing penalties to vehicles that topped the 80 decibel mark. The trucks had an even greater burden to bear in the weight pull. In this event, the drivers had to pilot their vehicles down a timed course carrying a total payload of 3,000 pounds. From this test, the judges learned if the students' modifications had in any way limited the practical usefulness of their trucks. The NGV Challenge wasn't just a muscle event. The teams also had to prove they had mapped out a plan for practical fuel economy in their vehicle design. To do this, the teams took to the open road in the NGV Road Rally. Laid out by officials of the Sports Car Club of America, the rally required teams to drive at exact speeds in order to test their fuel economy under everyday driving conditions. The vehicle's compliance with the assigned speeds was confirmed by surprise checkpoints timing the trucks along the route. The NGV teams and their trucks were also challenged during the week by a 250-mile endurance run, oral and written presentations, and several other events, all used to determine which team had best balanced the conflicting demands of high fuel economy, low emissions, and outstanding performance. When the results of all these events were tabulated, the team from the University of Tennessee was the big winner, driving their vehicle into first place with their innovation and hard work.
All three of us and many other team members that were on the team pulled all-nighter after all-nighter, and we're just happy that we managed to stick it out, and Lady Luck was with us, and we won the competition.
The other top finishers were Colorado State University in second place, Concordia University third, École Polytechnique fourth, and California State University Northridge in fifth. Winners of specific events included Cal State Northridge for Best Exhaust Emissions, Colorado State for Best Fuel Economy and Best Natural Gas Vehicle Design, and Texas Tech University for Best Acceleration. Of course, not everyone could place at the top in the 1991 Natural Gas Vehicle Challenge, but it was still an event where everybody won.
As a student engineer, this has been a tremendous competition because it's really helped us get hands-on experience, which is tough to get in the classroom. Competitions like this is where you really learn about engineering.
To actually get to do something that's not classroom work. It's something that we would encounter in the field as engineers.
There's a big difference between calculating a thermodynamic equation and going out and making an engine run at 13-to-1 compression ratio without overheating.
Besides the students, the other beneficiaries of the NGV Challenge are the auto industry and eventually the U.S. and Canada as a whole.
Something that will come out of this is that these students' designs will have a large impact on the decisions the automakers will make as they move towards mass-producing natural gas vehicles in the next 4 to 5 years. And in fact, I wouldn't be surprised to see some of the same engineers in this competition playing key roles in actually developing production natural gas vehicles.
Today, there are over 150 million gasoline-powered passenger vehicles traveling the highways of the United States and Canada. As one NGV Challenge official put it, America clearly has a love affair with the automobile. That's unlikely to change. But with the ever-increasing concerns about air quality and our increasing dependence on foreign oil, something must change. The 1991 Natural Gas Vehicle Challenge took the first step toward this change, using the unlimited energy and imaginations of student engineers to drive home the message that natural gas vehicles are feasible and practical. There is certainly more research to be done, but thanks to the students and sponsors of the 1991 NGV Challenge, natural gas vehicle technology is headed down a promising road to the future.